Good morning. My name is Lamar Mitchell, and I'm an auditor in the Quality Assurance section of the California Air Resources Board. So this morning I'm going to talk with you a little bit about background, what do we do and why do we do it. Then I'm going to talk a little bit about types of performance evaluations that we do. And then I'm going to talk a little bit about, I'm going to update you on some trace gas assessments. And then I'm going to talk a little bit about some new equipment that might be on the horizon. And at this point, I should let you know that I will use the words evaluations, assessments, and audits interchangeably throughout this presentation. So that when you see the word evaluations, think audits, because that's what we do in the quality assurance section. And then I'm going to turn the podium back over to Aaron Placencia, who will talk about the future in auditing technologies. So background, why do we do what we do? We do what we do, we audit because there's a requirement that there be an independent verification of the standards and the accuracy of the instruments that we audit. And we do this because there's a federally mandated requirement for ambient air data to be completed, to be compared to national standards. And we do this, we conduct audits using NIST traceable standards, and we adhere to federally established acceptance criteria when we're out there auditing your equipment. So now let's talk about the types of performance evaluations. In 2018, we audited 7 mass labs around the state. We audited 231 meteorological instruments, 270 gaseous analyzers, and 490 particulate samplers. And you say, well, why so many particulate samplers? There is a requirement that particulate samplers have a biannual review or audit every year, every 5 to 7 months. So we visit some of the sites twice in order to get those particulate samplers done. We travel throughout the state. Everything in blue gets audited. Everything in blue gets audited once a year. Some of the stuff in the yellow, the pink, and the orange down here are audited. Is it 20% a year, so that we hit all the sites in the state at least once every 5 years. That's important for you guys to recognize. There are 267 active monitoring stations approximately in the state. And we travel the entire state, so we go all the way up near the Oregon-California border and then all the way down into the California-Mexico border, or pretty close to it. So remember, evaluations and audits are the same thing. We do gases and particulate samplers. So let's talk a little bit about gases first when we are performing the audits. So we have contacted you and made arrangements to come out to your site, and we show up in our audit van, and we bring along our own analyzers, CO and ozone, and we hook up our probe line or our presentation line to your probe inlet so that we're sampling the entire, or we're auditing the entire sample stream. It is important to realize at this point that we bring our gas calibrator and our gas cylinder out. Everything that we do other than ozone is based on the CO gas that we carry with us. And then we send a known value of gas to your analyzer, and we compare your analyzer results to our analyzer result. So it's not just a single point that we shoot. Remember, when we send that known gas out, we send out a known gas to your analyzer, and then we compare. We don't compare the value that we get based on what we send out. We compare your analyzer to our analyzer. In addition to the gases samplers, let me switch gears here for just a moment and talk about the particulate sampler audits. Remember, back in the other slide, we talked about sending a known gas stream to your analyzer. We can't do that with particulate matter because it's not like clapping erasers back in middle school or elementary school. We have to do flow rate audits in order to calculate, to verify the value that your samplers are getting. So we actually use a BGI Delta Cal for the BAMs and the FRM 2.5s. We use the Tetra Cal for doing the SAS, Super SAS, Zontech, and TOMs. And then, of course, we use the high-vol direct read calibrator for high-vol samplers. That's your PM10 samplers. In addition to, let me talk a little bit about what we've been doing for trace gas assessments. Remember back in 2017 when we did the PQAO training, one of the things we took away from that is that we weren't doing a really good job of updating or doing trace gas audits. So what we found since then is that the US EPA sets these values here. Audit levels 1 and 2 have based on what the EPA has asked us to audit, the US EPA, they determined the correct standards that we need to shoot for. So we do audit levels 1 and 2, and up until recently, the last few years, we haven't done audit levels 1. What we have done is audit levels 3 through 7, and it is important to realize that at this point that audit levels 1 and 2 have an absolute value or PPB or percent difference, and all other audit levels 3 through 7 have a percent difference criteria, and that's when we look at your analyzer and the known gas that we send to your analyzer, that's what we compare to, is the absolute or the percent difference criteria based on the difference between your analyzer and what our analyzer is reading. And we thought, you know what, we can improve our confidence and reliability of the audits by looking at different things. And so one of the things we looked at was our CO analyzer performance, and we realized that the gas filter correlation technology, which most of the analyzers out there use, it is a very good analyzer, but it does have a known drift behavior, and it is intended for continuous sampling. There's a 3 to 4 hour warm-up period minimum, more like a 10-hour to get an accurate assessment. It works best if it's a continuous. Well, for trace audits, we found that 10 hours in continuous was not working for us. So we thought, well, what else can we do? So we needed to explore other options. Well, we've got generators on the vehicle, and we can leave the generators running all night, and we can leave the analyzers running all night, so that when we get there, we can have the analyzer having been warmed up for a continuous period of time. And we thought, well, hey, that works right. You know, we can set the analyzer running all night, and we can have the generators running, but what we found was that the next morning we got this. People are trying to sleep because, because the generators are too loud. They don't like people in the hotels. This was on the windshield of our vehicle in Bakersfield at the hotel because people are trying to sleep. They don't like the loud noise from the generator. So we thought, well, what else can we do? We can look at other systems besides the gas filter correlation technology, and we can look at a cavity ring down spectroscopy system. So we went out and bought one. They're $90,000 versus $13,000 for a gas filter correlation technology analyzer. And then what we did was we put the cavity ring down system, cavity ring down spectroscopy, and the gas filter correlation technology analyzers in parallel, and we went out and audited with that. And what we found, besides the warm-up time went from 3 to 4 hours to less than an hour for the warm-up time on the cavity ring down spectroscopy. And we found that the cavity ring down spectroscopy system was consistently on near the target values. In other words, there was no drift on our analyzers, which is a good thing. And so what we found when we did the pre and post zeros at Santa Maria, Stockton, and Fresno, we found in green the cavity ring down spectroscopy consistently hit zeros that were close to zero, whereas the gas filter correlation technology was all over the place, which was not a good thing. So this tended to skew our audits a little bit. And so what we found out was that when we were looking at audit level 1, 0.40 ppm, the cavity ring down in green again, consistently hit the audit level 1, which we were trying to do, versus the gas filter correlation technology in blue was all over the place. We had this high point here. We just didn't feel comfortable using the gas filter correlation technology. So what we did when we went out and looked at the trace level SO2 in 2018, again, the cavity ring down spectroscopy system in green consistently hit the values that we were trying to hit. The gas filter correlation technology in blue consistently was all over the place, or inconsistently, whatever you want to call it. But what this showed us, two things we got from this. One is that our SO2 network throughout the state was working as it's supposed to work. And for those of you that are operators and see us coming, that resulted in 5 fewer AQDAs in 2018, which I'm sure all of you will appreciate. So now I've gone through the trace gas audits. Let's talk about some new equipment. In the future, the T640 and T640X, which is scattered light spectrometry. T640X measures PM 2.5 and PM 10. The Thermo 5014I is a continuous BAM unit and measures PM 2.5. The API 602 Beta Plus is continuous BAM unit and measures PM 10 and PM 2.5 on filters. And then sometime in early 2020, we would expect to see a direct read NO2 analyzer, although they aren't really on board right now. So I'm going to turn the podium over to Aaron Placencia, who will talk about future audit technologies.
Thank you, Lamar. Again, my name is Aaron Placencia, and I'll be talking to you guys about future audit technologies, or things that we are looking at to use in the future. Quick overview, but what I'll talk about today, I will be going over the AIRPOINTER, which many of you have seen outside. I will also be talking about remote audits, UAV technology, and this use of a wind tunnel for MET audits. So just a quick look. Many of you have already seen it, but here are a few pictures of the AIRPOINTER. Here it is outside of our breezeway, and here it is out in the field. So just so you get a look at it. So going over the AIRPOINTER, we're going to go over a few of the capabilities that it has. It does have an FEM designation, so it can be used for regulatory monitoring. Again, it has one of the main selling points of it is the portability and mounting that it has. So obviously this thing can be transported all over the state and placed in many different locations for different reasons. In our AIRPOINTER, we have an API T640 as well as an ozone and NOx analyzer, also of which are API, but the insides of the AIRPOINTER can be changed to whatever your needs are. And then one of the other big selling points is the climate control. So obviously going out into the desert or anywhere that needs air conditioning, this unit can do it all. And again, this thing is outside and available for questions. If you guys have any questions about it, we can answer those. Anthony from Ambulabs is also here, and he can definitely answer your in-depth questions about this. Moving on. So with the AIRPOINTER, I guess we all have our issues. So these are our trials and tribulations of our experience with this AIRPOINTER. One of the big issues we had was establishing communication with the T640, and that came from the comm system between the AIRPOINTER and the T640 itself, but nuances that have been resolved. One of the other big things you'll notice is it does have a stainless steel inlet, which many of you might ask, how is that FEM designated when we've been issuing cans for having stainless steel in your sample train? This is going to be addressed, and it will be Teflon coated to meet those requirements. We have acceptance tested this AIRPOINTER to some extent so far, and I'll be going over the results in this next slide. We have conducted a through-the-probe audit of this AIRPOINTER, much like we do your stations. And then and the power requirements for this are a little bit more than your regular plug. We're told it uses about the equivalent of 2 microwaves, so you will have a bigger draw from this instrument, just something to note when you're going to place it out in the field. Okay, so comparing the ozone results, as you can see here, this is hourly data. The main thing to note here is that the AIRPOINTER is in green, and a regulatory station, which is our audit station there at 13th, is in blue. As you can see, it tracks very well. So we found that the ozone reads spot on with what we're reading, so that's a great thumbs up for that. Now comparing the NOx, as you can see again, the AIRPOINTER is in green, the regulatory station is in blue. What you'll notice here is there is a slight difference. The AIRPOINTER reads slightly lower than our regulatory station. So in finding this, we found that the NOx had to be recalibrated, and we've had some issues with that, but they have since been resolved. Now, comparing the PM data, we have, as seen on this graph, PM10 and PM2.5. The PM10 from the T640X is in blue, is in blue, and then the PM10 from the EBAM is in green. So the biggest thing to take away from this graph is that you see that they track very well. The biggest thing here is that the T640X is kind of known to read higher than the EBAMs, so hence the discrepancy here. As well as the 2.5, same kind of deal. PM2.5 for the T640 is in red, and the PM2.5 for the EBAM is in purple. Again, you see they track very nicely there, just the discrepancy in the numbers. So why did we get the AIRPOINTER? From our standpoint, from a QA standpoint, this AIRPOINTER can be placed inside of the community monitoring network to kind of, from a QA standpoint again, make sure that the community monitoring network is functioning properly as compared to the AIRPOINTER. It can also be used in areas of interest, some troublesome sites that maybe have some events that can't be explained, and it's nice to bring in another standard to kind of assess the situation. So for us, ultimately, it's going to be used for data validation or any kind of special circumstances. So looking forward, we're going to be looking into remote audits. So you might ask, what are remote audits? Remote audits is going to be the ability to audit a station remotely without you having to be there. And what that entails is going to be having a either dedicated or rotating audit system that can either go to one site and then move it to the next once you have your needs. Reason of which is we have some pretty remote sites, as well as some of you guys do in your networks, that are troublesome to get to. So it'd be nice to have an audit system already in place to where you can audit remotely and not have to physically be there. Just an example, we go to some pretty remote places, Joshua Tree and Death Valley. As you can see, they're out in the middle of nowhere. So once you have this audit system in place, you can conduct automated audits on your schedule, whether it be monthly or quarterly, however it be. Downsides to this, though, it's a big infrastructure cost. So obviously for every one of these sites, you're going to need to get another calibrator, a zero error generator, and certified cylinders. And of course, it does have its limitations. I would like to keep my job, I'm a traveling auditor. This might do away with us. But it has its limitations, to which it only applies to gases. And then you also have to do all the other stuff that we as auditors do, which is citing residence time and all the flows, which, as Lamar stated, happen twice a year. But one of the big pluses is you will have a referee instrument on site for troubleshooting. So if you have any discrepancies between your actual system and your audit system, this can help maybe alleviate a problem or figure out what's going on. So also looking forward to the future, we have been looking at UAV technologies. Many of you guys might recognize this and call it a drone. So drone technology can be very useful for having basically a bird's eye view of the site. As we do now, we just take a digital camera and take pictures all around of the site. This obviously would allow us to do some layer profiling and GIS mapping of the site, giving us a better view of what's going on when you're not physically there. One of the big issues with having a drone, though, is there are obviously FAA requirements. You can't just fly drones wherever you please. It is also a learning curve. All of us auditors have to learn how to physically fly this drone. And obviously, again, there's restrictions of where it can be used and how it can be used. So just future technology that we have been looking into and have the possibility of maybe one day using. Next, we're going to talk about the wind tunnel. So Hansa has worked very diligently to create and manufacture this, I will have you. He did a very good job. This wind tunnel, it will be used for ultrasonic MET audits. So as it is right now in the field, we do not audit ultrasonic MET. We just kind of take down your information for when it was calibrated, when it was installed. We will now be able to conduct audits in the field of these ultrasonic MET systems. And one of the biggest selling points, obviously, when you think of wind tunnel, you think it's this huge thing that is basically the size of a room. Well, we've kind of made it into this portable thing that can be transported and placed on top of a roof to conduct an audit, as you can see right there. So what are the biggest take-home messages of mine and Lamar's presentations is the audit program is evolving to reflect the latest requirements that are out in the field. We are always looking for improvements on current practices to maintain our integrity. We want to make sure that all the audits that we conduct and everything we do is valid and certified. So we're always looking for what's new, what's better, and we're always looking at what's the possibility of new technology that we can use in our audits to make sure that we're giving you the best and fair assessment of your systems. And with that, I would like to open it up to questions for either mine or Lamar's presentation.
Going back to the AIRPOINTER, where you're comparing the NOx values, was there any difference in the instrumentation on that, or was that a scrubbing that the AIRPOINTER was actually having on those values?
They're both API systems, but yeah, I think the main discrepancy was there was an issue with the NOx calibration on the AIRPOINTER.
Okay.
Does the EBAM that you use for the 640 comparison has FEM designation? And why did you use the EBAM and not something else, FRM?
Yes, I believe it does. And the reason we used the EBAM was because it was just transportability. We put it right next to the AIRPOINTER, and then we're able to compare the results that way. Because it's the AIRPOINTER was in the breezeway versus having the the BAMs that we have on the roof, it was easier just to compare it, a side-by-side comparison.